guys, welcome back. As promised in the last video, we're now going to talk about scientific notation. This is important. This is going to use our exponent rules as well. But let's just briefly explain what scientific notation is. We call it scientific notation because scientists most generally use this. It's basically a way to express gigantic numbers or tiny minuscule numbers in a shorthand way. If you're writing really large numbers, there's a lot of zeros, it takes up a lot of space. So this is just kind of an easier way to condense those numbers and not take up as much space when you're writing it. So the tricks to writing scientific notation, it's always written as the product of two numbers. And I'm going to tell you what the rules are for those two numbers. The first number has to be greater than or equal to 1, but less than 10. So it's going to, there's a range of numbers it can be. It has to be 1 or more, but less than 10. So it can be anywhere from 1.001 to 9.9999. Less than 10, greater than or equal to 1. And then we're going to write it times the second number. The second number is always a power of 10, meaning 10 and some exponent. There's nothing else for the second number. Always a power of 10. That's important. Because there's some quick ways that we can figure out what the number is. You don't have to sit there and try to do all the multiplication out. So here I'm going to look at scientific notation. And again, sometimes it's for big numbers, sometimes it's for small numbers. That's going to depend whether you have a positive or a negative exponent, whether it's a big or a small number. So first thing I want to do is I want to go back and I want to think about it. When you multiply by a power of 10, meaning 10, 100, 1,000, anything like that, what happens to the decimal point? The decimal point moves to the right. This is the important thing that we want to remember because it'll help us keep us straight when we're trying to write scientific notation in standard form, meaning actually writing out the number. So I just gave you an example here. If I have 4.756 times 100, if you'll recall the number of zeros that you have in your power of 10, or if you'll recall I can write 100 as 10 to the second, it would also be my exponent. I have two zeros, 10 to the second. I'm moving my decimal to the right 2 places. This becomes 475.6 instead. And if you'll recall, when you divide by a power of 10, basically your decimal goes the opposite way. So if I'm dividing by, here I've said 1,000, and again if I write this as an exponent, that would be 10 to the third. You'll notice there's 3 zeros. My exponent is 3. Little tricks to help you remember. So I'm moving my decimal 3 places, but now I'm moving it to the left because it's getting smaller because I'm dividing. So here you'll notice I started here, 1, 2, 3. I moved it 3 spots. I had to add a 0 placeholder here as well because of the way I was moving my decimal. So you need to keep all that in mind when you're doing these things. So this is kind of the basis for getting our scientific notation down. So when we want to write numbers in scientific notation, here I've given us a really big number to start with. This is a big number. It takes a lot of room to write all those zeros. So we're going to write it in our shorthand scientific notation way. So the first thing we want to do is we want to look at where can I put the decimal to make this number so that it is greater than or equal to 1, but still less than 10. Well, what I notice is if I put it right here, and I've already drawn it in there, I get 4.4. Remember with a decimal, all these extra zeros, they're not necessary. So 4.4, greater than 1, less than 10. So that falls into the parameter. My first number is going to be 4.4. Then what we want to do is we want to count how many places I moved the decimal. So remember, if you can't see the decimal, it's at the end of the number. So I said I want to move it to make this 4.4. So we need to count how many places we moved our decimal. And if you'll notice, I drew my little, I like to draw the little loops as I count. It helps me keep track here. I moved it 9 places. You count backwards. You'll notice I didn't just count the zeros because I moved the decimal here, so this 4 also counts. So don't just count zeros. That's not going to help you. You need to know how far did I move my decimal. I moved it 9 places, so that gives me my power of 10. So the base is always 10. It's 10 to the 9th because I moved my decimal 9 places. So I write it as the product of these two numbers, 4.4 times 10 to the 9th. And we'll do a few of those to practice. And the important thing to remember here is what you want to think of when you're doing this is my number getting bigger or is my number getting smaller? And that's going to tell you whether it's a positive or negative exponent. So here, first I have to think, where am I going to place my decimal so that my first number is greater than or equal to 1, but less than 10? Well, if I put it right here, that makes my first number 2.5. So I'm going to write that down. 2.5. Now I just need to figure out what my power of 10 is. So how far did I move the decimal? 1, 2, 3 spots. What you'll notice, though, is I moved it in the opposite direction. 2.5 is the number I'm using down here. If I look up here, this is a smaller number. 0.0025 is smaller. So that means it's a negative exponent. It's becoming a negative 3. The other thing you can remember is that if you're moving it to the left, and the problem with remembering left and right, if it's positive or negative, is it's going to be backwards when you're converting it the other way. So I don't want to confuse you with that. So what I like to do is just think of it logically. This number, 2.5, is getting smaller, so it's negative. If it were getting larger, it'd be positive. But here, remember, if you're moving your decimal to the left, it's going to be a negative exponent. If you're moving your decimal to the right, it's going to be a positive exponent. But that can get confusing, like I said, because what we're doing here is we're taking this as the standard form, we're writing it in scientific notation. On the next board, we're going to look about going the other way, taking the scientific notation and writing it in standard form, where these two rules are going to flip-flop. So I don't want to confuse you that way. So again, here I'm going to look at where can I put my decimal so that my first number is greater than or equal to 1, but less than 10. If I put it right there between the 6 and the 4, I wind up with 6.4. Is that less than 10? Yes. Is it greater than 1? Yes, I'm good. It's always going to be times 10 to the power of something. So how far did I move my exponent? Well, it started here. I moved it 1, 2, 3 spaces. 6.4, this number is larger, so 6.4 is getting bigger. That means it's a positive exponent. So it's 6.4 times 10 to the third. All right. Here you'll notice I have a negative number. This does not affect your exponent. Don't let that confuse you. And I know I said it has to be between 1 and 10. It could also be between -1 and -10. So the negative is just going to stay in front of my number. It's not going to affect my exponent in any way. So first I look at it, where can I put my decimal? If I put it right here, I wind up with negative 5.42. Remember, the rest of the zeros beyond that don't make a difference. So keep your negative sign. It's between -1 and -10, so I'm good. Times 10, and then we have to figure out what our power is here. Now you'll notice here the number is getting bigger, moving the decimal that way, so it's going to be a positive exponent. So, and then again, just count how far did I move it. 1, 2, 3, 4, 5, 6, 7. I moved it 7 spaces. That gives me my exponent. All right, over here again, where are we going to place our decimal to make it between 1 and 10? 9.09 is less than 10, greater than 1. Then I just need to determine my exponent value. Again, notice I have 9.09, so I'm going to a smaller number, so that means it's going to be a negative exponent. How far did I move my decimal? 1, 2, 3, 4, 5 places, 10 to the -5th. So it's 9.09 times 10 to the -5th. So more to look at here. Again, first thing, where am I going to put my decimal? Right there between the 6 and the 1, because 6.1 is greater than 1, less than 10. Second number is always a power of 10, so it's going to be times 10 to a certain power. How far did I move my decimal? 1, 2, 3, 4, 5, 6 spots. 6.1 is getting bigger. This number is bigger, so it's a positive 6. Again, here you'll notice this number is negative. Doesn't affect your exponent. Just means that down here, when I move my decimal, this is going to be between -1 and -10. So if I move my decimal right here, I wind up with -3.29. That is less than 10, greater than 1, so I'm good for my first number. Second number is always a power of 10. What you'll notice is this number is now getting smaller, or the decimal is moving the other way. So how far did we move it? So that means it's a negative exponent. How far did I move my decimal? 1, 2, 3, 4, 5 spots. 10 to the negative fifth. All right? So really it's just a matter of moving the decimal, counting how far you've moved the decimal. Broken nail. It's tragic. All right. Now we're going to look at going in the opposite direction. If I give you the scientific notation, how do we write that in standard form? And standard means I want to write the number out. So I have 1.8 times 10 to the negative third as my example. The negative exponent tells me it's going to become a smaller number. The negative or the positive tells me basically which way I'm going to move my exponent. So look at the power of 10. That tells you how far to move the decimal. I'm moving it 3 places. It's a negative exponent, so I'm moving my decimal to the left 3 places. If it was positive, I'd be moving it to the right that number of places. So here I said I want to move it negative 3 spots. So it started out here between the 1.8. So if I move it 1, 2, 3, and I have the little bumps so that you remember to add in your 0 placeholders, it actually becomes 0.0018. So we're going to take a look at that as well. So here I have 2.5 times 10 to the negative third. This is the important number right here. This is telling me how far to move my decimal, and it's telling me I want to move it, negative means to the left. I want to move it to the left 3 places. So I'm going to rewrite this number here. So if you look, I count and I make my little loops. 1, 2, 3. So my decimal is going to wind up here. What you'll notice is I got 2 little potholes. I need to drop eggs in them. 0. So what would that be? That would be 0.0025. Over here, I have 10 to the 0 power. This is kind of pointless to write in scientific notation because 0 tells me I'm not moving my decimal, so that just means this is 7.83. Here, I have 2.925 times 10 to the negative second. So this is telling me I am moving my decimal negative 2 places or 2 places to the left. So 1, 2, drop in my 0. I wind up with 0.02925. All right, and always make sure that you're rewriting it here so that it's nice and neat and I can see where the decimal is. Some kids draw their loops and they forget to move the decimal and still try to put it there. It's no longer between the 2 and the 9. We've moved it because now it's in standard form, so we've moved that decimal. So here you'll see I've got negative 9, which means I'm moving my decimal 9 places to the left. So I'm going to rewrite this here, and I'm just going to make my loops, and I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my decimal is going to wind up here. Wherever I have a hole, I need to fill it in. And then I just rewrite it so that it's nice and neat, and I can see exactly where the decimal is. Decimal now at the beginning. It's no longer here. We moved it. We moved it 9 places. And remember, it's not a number. It's not a matter of just adding that many zeros. A lot of kids try to do that and just add zeros. That's not the case because I still had to move the decimal beyond the 4, which counted for 1. So don't just try to add that many zeros. You're moving the decimal. All right, here I have a negative 4. So it's telling me I'm moving it 4 spots to the left. 1, 2, 3, 4. Drop my goose eggs in. I wind up with 0.00071. Here you'll notice my exponent is positive, which means I'm now making the number bigger. My decimal is going to actually move to the right instead. So if I have a 6, remember the decimal is after it. If you don't see it there, there's an implied decimal after the whole number. And just count 7 spaces. 1, 2, 3, 4, 5, 6, 7. And my decimal winds up at the end. Again, we need to fill all of these in with zeros. Fill in our holes. So what I wind up with is a very large number, 60 million. So we can either go bigger, we can either go smaller. It's just a shorthand way to write different things. If you're confused at all on that, please feel free to ask questions, write them in the comments, email me, talk to me in class. Also, remember, you can rewatch the video if you need to. Have a great night. I'll see you guys tomorrow.